The triple scalar product is, again, one of those more obscure concepts that we'll learn about in this course that relates geometric objects to these operations that we've defined on vectors. So if I have three vectors, u, v, and w, and assuming that none of them are parallel to each other, if I were to think of those as three random vectors and create a parallelepiped similar to like this, where I create the parallelogram from u and v, and then I create, it's almost like a kicked over rectangular prism to get the parallelepiped. If I were going to construct that in space and I wanted to figure out what the volume of that object was, what I can do is I can take the vectors that represent the sides of this parallelepiped and I can compute this scalar triple product u dot v cross w. So there are practical reasons that you would want to do this. Think in manufacturing or engineering when I want to compute, what the volume of an object is going to be. If I define something like this, I can figure out just the sides of it and I can completely deterministically understand the volume of it. But to compute that, what we're going to do is use we use a process that's very similar to the way that we compute the cross product. So we're going to set up that same sort of, I don't know what the term for it is, but we're going to set it up similarly to the way we would set up a cross product, but instead of the ijk's being on top, they're actually the value of the components of the u vector. And we're going to, same way, if we go left to right, we're going to add them, and if we do right to left, we're going to subtract them. So let's compute that. What we're going to find is we have u1 v2 w3 plus u2 v3 w1 plus u3 v1 w2 minus u3 v2 w1 minus u1 v3 w2 minus u2 v1 w3. So if you have to compute a scalar or triple scalar product, you could follow this process and you'd end up with 6 unique terms that you needed to sum up together. One last point I'm going to make is, notice that it says that the magnitude of this quantity is the volume of that parallelepiped. And the reason we say the magnitude is that if u dot v cross w, it could end up being a negative number, right? Dot products can be negative. But obviously the volume is not a negative quantity in the case, in the way that we normally think about it. So we take the magnitude or the absolute value of the number that comes out of here when we're thinking about the volume of a parallelepiped. But other than that, that is the triple scalar product.